Great. Good afternoon, everyone. My name is Dustin Sachs. I'm Director of Research for the Institute for Critical Infrastructure Technology. I want to welcome you all here for our webinar today on open source software. The Institute for Critical Infrastructure Technology is a nonprofit, nonpartisan 501c3 think tank dedicated to improving the security and resilience of critical infrastructure that provides for people's foundational needs. For the past decade, as the only think tank focused exclusively on critical infrastructure, we've built a tremendous community and following and have done a lot to advance the security and resilience of critical infrastructure along the way. This is a vital mission for our nation and people, especially in the times in which we're living, when our digital, physical, and human domains are converging, rapidly changing, and none of what we do or have done would be possible without the dedicated and generous support of our sponsors and donors, like Cloudbees, whose support made today's event and some of our other work in securing open source software possible. We'll learn more about Cloudbees and the incredible work they're doing today and have done for nearly a decade and a half to innovate, modernize, and secure software later on in our webinar. So thank you to Cloudbees for your support and partnership. And it's my honor to introduce today our panel, starting with Mark Maxwell. Mark is a security and compliance specialist at Cloudbees. Mark is an analytical information security professional with proven expertise in cybersecurity tools, design, implementation, and operations. He is dedicated to driving efficiency and productivity through architecture, delivery, and support of strategic plans. Mark has a bachelor's from the University of Phoenix in computer systems, networking, and telecommunications, and earned an MBA in international business from Salem University, which is a university in Corey's home state of West Virginia that has an exceptional international business school thanks to a partnership with Tekyo University in Tokyo, Japan. Also joining us today is Dr. Ron Ross. Dr. Ross is a fellow at the National Institute of Standards and Technology. He has dedicated his life to service to our nation, beginning with attendance of the USMA or West Point, followed by a 20-year career in the U.S. Army, and for the past 26 years has served in various technical and leadership positions at NIST. Dr. Ross is a pillar in the technology, standards, cybersecurity, and risk management communities. Ron is also an ICIT Fellow and a 2019 recipient of our Pioneer Award, our Institute's highest award recognizing individuals whose leadership and lifetime commitment to public service have fortified critical infrastructure and transformed national security. This is certainly true of Ron, and we're lucky to have him joining us today. Finally, we're joined by Corey Simpson, who is the CEO of ICIT, as well as the CEO of Grace-Based Strategies. And I'm having slight computer. There we go. Corey has over 20 years of experience in government, the military, and the private sector at the intersection of national security, cybersecurity, business, law, and strategy. He is known globally for developing and delivering simple and elegant solutions to the most complex and novel challenges. Corey served on active duty in the U.S. Army Judge Advocate General's Corps from 2004 to 2016 and continues to serve in the Army Reserve as a legal advisor to the U.S. Army Cyber Command. Corey has spent most of his military career as a general counsel, prosecutor, and national security law advisor. His highly decorated service includes multiple combat tours, leadership roles, and extensive trial and advocacy experience. Corey is the CEO of Grace-Based Strategies, a professional service and strategic advisory firm, and CEO of the Institute for Critical Infrastructure Technology, which, as we've said, is a nonpartisan, nonprofit think tank dedicated to improve the security and resilience of critical infrastructure that provides for people's foundational needs. Corey also serves as an advisor to the CSC 2.0, a nonprofit, nonpartisan entity that continues the work of the U.S. Cyberspace Solarium Commission, and is a member of the board of directors for the Cyber Guild, a nonprofit organization formed in the belief that the world will be more secure when cybersecurity is part of the fabric of everyday living. Corey earned a Master of Laws in Military Law from the Judge Advocate General's Legal Center and School, a Juris Doctorate from West Virginia University College of Law, and a BA in Accounting with a minor in Philosophy from Transylvania University. Thank you, gentlemen, all for being here today and for being a part of this panel. So today our topic is about talking about how we can secure critical infrastructure, specifically when it comes to open source software. The most important thing to consider when we think of open source software is the fact that there was a recent report that came out that said that it's estimated that 70 to 90% of all software stacks comprise some element of open source software. And if you're one of the 2.5 billion people in the world who use an Android device, your device's operating system is actually a modified version of an open source software. So this idea of open source software permeates everything that we do in security and in technology. So starting off, the first question that I'd like to ask the panel is, how do you define open source software? What is it? What is it not? And we'll start with you, Mark. Oh, Mark,
I think you're muted.
I think you're muted.
How's that? Better?
There we go.
All right. So start over. So thank you, Dustin, and the panel, and everyone attending today and setting aside some time in your busy schedule. When I look at open source software and what it is that I'm characterizing it and defining it is looking at it and its ability to be accessed, modified, and have multiple contributors to look at the actual source code in a legal capacity. This paradigm shift of how software is created, where it used to be versus with the open source model, it's different than looking at an enterprise software like Windows as a comparison to like Linux. Software is no longer a proprietary secret. Instead, it allows for more transparency in that perpetual development. And it's a community-based approach to improve the software. Looking back into the 80s, I can remember free software that was released, but it really wasn't where you had access to the source code itself initially. But then other projects popped up like Linux, Apache Server, Firefox, WordPress, and others started to pop their head and giving developers an opportunity to be a part of that initial conception before and shaping it into what the consumer would actually see. More collaboration, more freedom, and it really started to encourage more that innovative spark of what could be, because you had so many different people involved in shaping what that source code may have initially been thought of, but then how it grows and develops into something else. And it's not just the developers themselves and the software architects. You have the ability for business owners, technical writers, product managers, testers to actually be part of that process. And while they're not writing the code, they could be suggesting user stories or documentation, other artifacts that are necessary for the development of the software.
Dustin, you're muted now.
Dustin, you're muted.
We'll get there.
Thank you. Thank you. I was saying is I want to encourage everybody, please, if you have questions throughout, please submit them using the questions option within the webinar, and we'll address questions at the end. Corey, from your standpoint, how do you kind of define the scope of open source software?
Well, I mean, I would say being a lifelong public servant, I would refer to NIST, which I happen to know we have an expert from that organization here with us. So I would defer, but I think just very simply, it's a software for which the human readable source code is made available to the public for use, study, reuse, modification, enhancement, redistribution. And with that, I will turn it over to Dr. Ross to orient left, right, and offer some thoughts.
Yes, please.
Well, yeah, I don't disagree with it. Both of those definitions are good definitions. I was thinking back almost 25 years ago, we participated in a White House study to try to determine which was more secure, open source software or proprietary. And at the end of the long study, the conclusion was that you couldn't really say either way which was more secure. They both had their pros and their cons. What I would say is whether you're using proprietary software or open source, they both kind of have to go down the same road with regard to quality and assurance. And I say that in the context of what we witnessed in the last decade is it's a massive convergence of cyber and physical systems. And you can see this in every aspect of our lives where computers driven by firmware and software are now driving these mechanical systems or physical systems. Your car, for example, over 100 computers in the car controlling not just the entertainment system, but the braking system as well, critical functions. So it's really appropriate that we're having this webinar today as part of ICIT because one of the things we've seen in the past couple of decades is an unparalleled growth in technology, and that's translated to just an explosion of complexity of systems. And that would be hardware, software, firmware, all those components coming together. We have trillions of lines of code, billions of devices, and everything is connected ubiquitously across a global network of communication systems. So that complexity from a security standpoint equates to attack surface. And that's what we in the security business worry about. And so we talk about managing and reducing complexity. And part of that discussion goes to what do individual developers of software products, which are not just going into entertainment devices, which if they fail, it may be irritating. The old blue screen of death was irritating, but nobody died. But what is going to be our standard of due diligence or due care for the industry players who are producing these great technologies, knowing that they're going to go into critical systems? Open source, as you said, is a huge part. I think 70, 80% of software today has some elements of open source in it. And that's not surprising because there's a lot of code libraries out there that are imported. So the question to me becomes, what is going to be the standard of due diligence? What is expected of software developers on the open source side or the proprietary side to ensure that their customers have sufficient transparency to understand, should I use this product in the situation that I'm using it? What are the risks to me as a consumer? How much do I need to know? Some of that talks to the SBOM world. We're trying to get consumers more involved in the process so they have some assurance that when they use these products in the systems that they're using them, they can have some degree of trust that those systems are going to do what they say they're going to do under the circumstances in which they're being used. It's a great topic for today, and I think the open source community is going to play just a critical role in moving forward as they've done in the past.
Great. Thank you so much for that. So throughout this webinar, we're going to do two things. First of all, we'll have a couple poll questions as well. At the end of the webinar, you'll receive a survey, and I want to just thank Cloudbees. Cloudbees has been gracious enough to offer a $20 charity gift card to those who fill out the survey post event. So please keep an eye out for that. But with that, we'll start with our first poll question. The question really is, how frequently does your company or your organization utilize open source software in its operations? We'll give everybody a minute or so here to answer that. And while you're answering this, I'll certainly share. I shared with the panel in preparation. The organization that I work for, um, we develop a lot of our own software, and one of the biggest challenges we face is the use of open source software and the use of integrating that into a proprietary piece of software, as we've seen, in previous attacks, and the one that I used in our prep was, the big one, Log4j. I mean, you see the impact of a single piece of software and a small single piece of software, and what it can do, and the impact it can have when you're not appropriately tracking, or you're not addressing open source software appropriately. And I think, as all the panelists have said, the whole SBOM concept is really going to add a level, and adds a level of intrigue and interest into this. So at this point, I don't see anyone else sending in their results. I'll share the results because I think it's interesting, but it's really interesting to see that, yeah, as we kind of expect, most people are using open source software at least daily, overwhelmingly. So with that, Ron, starting with you, what do you see as the most important considerations for agencies and organizations that are considering or already leveraging open source software?
I think getting back to the the whole notion of complexity in the attack surface, every organization, whether it's public or private sector, if they're using a piece of open source software, I think it's important to work with the developers of that software to understand what they've done as far as their due diligence. This could talk to the design techniques they use, the secure coding techniques. There's a whole range of things in software. It's not just the functionality that's delivered by the software, what it can do as far as the functions that it provides, which can be very important in and of themselves. But how much assurance do you have that those functions are actually built correctly? And the organization, the development team, did everything they can do to reduce the weaknesses and deficiencies in that code to the best of their ability using best practices. All of those weaknesses and deficiencies that are unattended to or that are missed during that development process, those could potentially turn into vulnerabilities once that software makes its way into the systems used by customers. And at some point, it becomes potentially very difficult to find. You mentioned Log4j and the things that the nightmare that caused. That software is used extensively. Just trying to find everywhere a piece of code is used in these very complex systems can be a challenge in and of itself. So as we go forward in time and our dependence on open source increases, I think we're going to have to raise the bar on our expectation of assurance from the developers of the open source. I'd like to see it be a competition, if you will. This one source open source developer says, I've done X, Y, and Z to help my customers understand what I built, how I built it, and what I've done to mitigate those risks of the weaknesses and deficiencies that traditionally come out of any code development process. So if we can establish some kind of a standard or expectation, whether it's government, industry, or academic community, on what that would look like, I think that's going to go a long way to giving people that the trust they need in using these components in their critical systems.
Mark, what are your thoughts? What do you see as the most important considerations?
A couple different points, and this is just conversations that we've been able to identify with our customers themselves. Is looking at that enterprise level of support. When looking at an open source solution, oftentimes you're not going to get that quick turnaround and response when deficiencies are found or vulnerabilities are identified, or just the simple use of the system itself. Long-term organizations are going to want to ensure that the software that they're employing or into their enterprise is going to be there, and it's going to be supported. And then to Ron's point of having visibility back into the development and the developers themselves of what was the risk framework, the approach, the best practices that were employed when they were developing the software, and then also, any of the possible dependencies within maybe open source libraries that they had ingested and used in the code themselves. Where's that traceability, and what are they doing for ongoing identification of vulnerabilities within those?
Great. No, those are really great points. Corey, when you think about, critical infrastructure that, affects it fundamentally affects people, what are your biggest considerations? What do you think of in terms of the leveraging of open source software?
Well, I mean, as it relates to critical infrastructure, I think it's important to note that open source software is um, a part of the foundation of every sector of critical infrastructure and every critical function. So it's vital that we figure out how to secure it, how to get visibility on it, traceability of it, and then ultimately accountability for the security of it. But that's, a very difficult thing to do. I know the National Cybersecurity Strategy is getting after that. And CISA has certainly put out a great roadmap. It was released this fall for kind of highlighting everything from threat models to risk management frameworks, suggestions for prioritization, and some tools. If you've not seen that, I would recommend taking a look. But for me, the most important thing, and it's even visibly depicted here with the diverse perspectives that we're getting. We have a nonprofit, ICIT, we have NIST, that is a standards body, and we have Cloudbees, which is an actor in the ecosystem, providing services. And I think when you look at it, it takes this community of interest to come together, because open source software is ultimately a community build. It's global. It takes people with diverse skill sets, and if you're going to have security in that sort of an ecosystem, it's going to be a shared responsibility, and one that is going to require transparency with what each entity is doing. So that's sort of, I think, as it relates to critical infrastructure and sort of the community that it takes to bring security to it.
Absolutely. Mark, coming back to you, what are you and Cloudbee seeing, as the key challenges uh, when it comes to the usage and governance of open source software?
Um, a couple, again, identified points. We're constantly working with our customers and understanding the challenges that they have, and how do we, in essence, make things better, to solve those issues. And with the Cloudbees, the solution that it is, we've looked at and identified is a couple things. One is scalability. When you take an open source solution and you implement it into a smaller organization, that's one thing. But then when you start to scale it to hundreds or thousands of instances within a company, it becomes a critical piece of the overall business function, and ultimately impacts the profitability and what that business is trying to deliver. Then looking within the layers, the security of what's implemented to create the solutions that are out there. Yes, you have this huge broad community in the open source that will be looking at new code that's developed. So an organization maybe that's developing has, say, 20, 30 developers, and of that a subset, a third of those can do the actual testing. Whereas in open source, you could have thousands of people that are introduced to look at those vulnerabilities, that are identifying them, trying to minimize the threat surface that's introduced. But in a way, you're also kind of providing some opportunities for threat actors themselves to have direct access to the source code, and in their contributions, may have the opportunity to ingest libraries that have dependencies elsewhere, that would introduce vulnerabilities that were unintended. Um, you know the way organizations, companies are looking to implement software is they look at it a couple different ways. And one is, what are the benefits and what are the risks? And it needs to be weighed on both sides. It's not to necessarily say one is the better, one size fits all. Each organization needs to look at on a case-by-case basis when they're looking at an open source software and implementing that, but having the proper set of controls in place, like a central authority, a central source of truth, ongoing security controls when you're developing the software, ongoing the ability to produce automated SBOM evidence required for these audits. All of these are fundamental pieces that companies are looking and wanting out of an open source solution, and not necessarily finding all of that together. And it's a bit of a struggle when they're looking at, well, here's a solution, it has a cost benefit, but you just can't look at it at the surface. You need to look at it again as a whole, evaluate it on a case by case basis, and see truly where that the risk offsets the benefits or not of using open source software as opposed to an enterprise supported solution.
Great, thank you for that. Ron, from your perspective and from the NIST perspective, what are you seeing as some of the key challenges that organizations should be thinking about when they're looking at how do we use, or how should we use, or how should we govern our use of open source software?
Well, I think just having heard the discussion, I think one of the problems we have is we adopt buzzwords like secure by design. Sounds really good, and it's becoming fairly widespread now in its use. And I think that kind of sets up a straw man, because if you look at the complexity we talked about these systems and how widespread all of these software products are used across the globe, there really is no such thing as a secure system or even a secure piece of software. You would have to go back a long way to the days of the Orange Book and the trusted computer systems evaluation criteria, where there were systems built, operating systems that were at a very high level of assurance. So I think that the operative word here is trust. How much do I trust any piece of software that I'm going to buy or integrate or have an integrator use to build the system that I need to do my job or to carry out my mission? And so that goes back to, again, this notion of assurance and the amount of trust you have. So we assume there's no perfect security ever. There are no secure products or systems. So which ones do I choose? And that gets back to, what did the developer do to increase my trust in that product? And I think that gets to transparency, visibility, the different techniques and approaches the developers used, how much information they're willing to share with the consumers. And let's face it, consumers are not software experts. It's, the example I love to use is, I've been driving now, it's hard to believe, almost 60 years. I know way before you guys were even.
You don't look a day over 25, Ron. What are you
Well, I've been
talking
driving a car a long time, and I can remember back in the days when cars didn't even have seatbelts, and then we had seatbelts and they were optional. Our airbags came in and the airbags were optional. In fact, my first new car, I was a second lieutenant. And I remember sitting there with the dealer, and they said, you can get an airbag as an option, or you can get an 8-track stereo. So those of you on this podcast don't even know what 8-tracks are, but that's how we used to listen to music back in the day. But the point is that over the years, the auto industry started to build safer cars over time. And some of that was regulation, and some of that was just they wanted to give their customers safer products. I think there's an analogy there for the software industry, because when you get in that car and you put the seatbelt on, you got the airbag, you got the steel reinforced doors, the drop down engine, all the sensors that I depend on now to drive at my age. Those things over time became standard features on the cars. And so I think we have an analogy there for the software industry, whether it's open source or otherwise. It's a commitment to bring better security features to their products, to make those products more secure. I won't even use the term secure. And then the other half of that, how do you convince your customers that what you've done is the appropriate things to do? you built the product correctly to the best of your ability, you followed best practices. And that gets back to sharing the types of processes you use to develop the software, the evidence that's produced as part of that lifecycle process. Every product goes through the same lifecycle development, and evidence of what you've done during that process is produced during that lifecycle. And that's some of the things that feed the SBOM process. But SBOMs can be all over the place. There could be a little stuff or a lot of stuff in that SBOM. So the question is, how much as a nation and an industry and the government industry partnership, how much are we going to end up saying this is about the right level of due diligence to make sure that when you produce the greatest software on the planet, I have some level of trust, either zero trust or 100% trust. And that can be all over the map, depending on how much the developer is willing to share about how they went about producing the software that they're producing. So I think I go back to that's the critical issue. There's no doubt we can produce the greatest software. We have the best industry in the world. We're producing the greatest software. But that's not the issue anymore. We know it can do everything functionally, but can I count on it to do the things it's supposed to do in the heat of the battle? Is the pacemaker going to work all the time? Is that power plant, the PLC in the power plant, not going to be subject to subversion by a nation state adversary and turn the lights off? Are my brakes going to fail because an adversary implanted malicious code in that operating system that is controlling the braking system of the car? Those are the critical issues of our time because of our total dependence on these great software products that we're integrating into these cyber physical systems. That's where I would focus. I think that's a big challenge, but I think it's something we can do. We can kind of coalesce around this notion of due diligence for open source software, trustworthiness, if you will.
Yeah, I mean, I think you bring up a really interesting point, Ron, which is the margin for error when something goes wrong is becoming less and less and less every day. And when you throw in AI and some of the speed at which AI can do things, it even lessens it. We're gonna go to our next poll question. If you're unable to see all the answers, please make sure to scroll down. But the question is, what is the most common problem your company encounters when deploying open source software? And we'll give everybody a kind of a minute here, but I think there are some interesting challenges obviously with open source software, and it is tough there. We keep talking about trust and transparency and SBOMs, which is all about transparency. And I think that to me is the biggest kind of challenge, is ensuring that you can have the transparency you need to make the best decisions. We talk about a lot about uncertainty and a lack of not liking having uncertainty. My doctoral research looked at the concept of uncertainty in risk decision making, and it was very striking to see how much that concept of needing to have some level of certainty plays in decision making. So open source software just adds a whole another level of complexity to it as well. We'll give everybody another couple seconds here, and we'll share some results here in a moment. Okay, so again, I think it's interesting here again that uncertainty about long-term maintenance was an overwhelming problem. That again, back to that uncertainty, and how do we keep it maintained? How do we ensure long-term maintenance? As we kind of jump back in, Corey, you and I have had several conversations about some of the existential threats and the nation state threats that we face, and I think open source software, especially how much it permeates critical infrastructure, really opens up and demonstrates some interesting issues. And so the question that I would ask is, what do you see, what are the key risks or the key things that the key, possibilities that organizations should be worried about if open source software is not properly managed?
Well, I mean, ultimately it's the infrastructure that we rely on every day for food, water, shelter, healthcare doesn't work. And that's we don't want to see that happen. I mean, Volt Typhoon was a unique, or is a unique threat in the sense that it was placed on our critical infrastructure for disruptive purposes. So I think we're seeing a very different approach to holding critical infrastructure at risk. And I think that certainly open source software community, that's going to be a rich environment for targeting for nation state actors, because of the point that I made earlier. Open source software is a part of every critical infrastructure sector in every critical infrastructure intersection, or the critical function. So what I do want to, Ron, to something that you hit on, and I do want to pull the thread on that genuinely, because I'm interested. It strikes me. I did an event not too long ago with a gentleman that laid forward that trust is the new attack surface. That really that is what adversaries are holding at risk, whether it's trust in our institutions, in our democratic values, our democratic systems, but and I hadn't heard anybody put it in this context of like trust in our technical systems. And I'm interested to see, or to get your thoughts on the distinction between, like, how do we get trust if it's not secure by design, if that's not the right message? Like, how do we ensure it's secure enough that we can trust it? Like, how do we reach that standard, if you will? And I know you've certainly given a lot of thought to standards. So how do you think about that?
Well, the reason why I think it's impossible to ever have a fully secure system is because of the complexity issue. We're talking about operating systems that are over 100 million lines of code. And one of the principles of security is to make things as small as they can be, to understand what you've built, how you built it. And you basically try to increase your level of trust that that system is going to do only the functions that you designed it to do and nothing more. That's been kind of a foundational principle, and we've blown by that principle many times over, orders of magnitude in complexity, which makes it virtually impossible to get things small enough. And I think a lot of that is it takes discipline in the process to keep the number of functions. There are two things in cybersecurity that are very foundational: least privilege and least functionality. And what those mean, it talks to the smallness of a system. And the reason we like that is because as systems get larger and more complex, it becomes virtually impossible to cover the entire set of lines of code with regard to understanding the potential weaknesses and vulnerabilities that are in that code, even with artificial intelligence and all of that stuff that we can bring to bear. The attack surface complexity theory in computer science trumps everything. And so it's that lack of discipline. We try to put out software and systems that have high degrees of functionality, general purpose operating systems that can run any type of application. There are different operating systems out there that are much smaller. They allow only a single level of functionality or a small group of functions to be executed. There's a term I used to use back at the National Security Agency called trusted garage door opener. It does one thing. It opens and closes your garage door. It's a very small amount of code, but it does it with bulletproof effectiveness and security. In other words, you can, through whatever methods you use to guarantee that code was correct, whether it's formal methods or other methods you might use, you can guarantee that device did only the things it was supposed to do and nothing more. If you compare and contrast that with the complexity of the systems, the trillions of lines of code and the billions of devices and everything is hooked up to everything, we just flat don't have a handle on everything we built or how it's deployed. And I think this gets back to the fundamental standards that we built as part of the FISMA project early. I think it was 2004, 5, and 6 timeframe. FIPS 199, it had the 3 impact levels: low, moderate, and high impact. Basically, you ask every customer, is your information low, moderate, high impact? And is your system low, moderate, or high? And what that means is its impact on your mission if that system fails or there's a breach that brings it down. So one of the things we're going to have to do is figure out, where are we deploying all of this open source software? If we can even get a handle on that, what critical functions is that software a part of? And are we doing the best we can to reduce and manage the complexity of those critical system elements? You may not be able to use a general purpose operating system in some of these devices or systems where you just flat don't have a clue about all those hidden weaknesses and deficiencies that the adversary will find, because in the world of complexity, 0 days are a thing you can count on. The increase in the number of 0 days is to continue to grow as that attack surface and that complexity grows. So in some sense, I believe this becomes a test of wills, or the cultural will to do the right thing. Sometimes you get flat addicted to the technology, and as long as your screen doesn't go dark, or your brakes don't fail in your car, or the lights don't go out, you just keep on going down the road fat, dumb, and happy. And so that's, to me, what we have to really do. We're going to have to get a handle on this stuff at some point in the future, because we're building it out faster than we can understand what we built or the potential adverse impact on our society if that power plant gets attacked and that those generators burn up and they can't be replaced for 4 months, 5 months, or 6 months. Think about that and the effect on society. You talked about that, Corey, the effect on society overall. So trust, to me, is not about perfect security. It's about understanding what the developers have done, and is it good enough for where I'm going to use it. And if it's not good enough, then we need to up the bar, raise the bar on those pieces of software that are going into those critical applications. We're certainly not there yet. I'm not even sure we're ever going to get there, but I think that's the discussion that needs to be had, and sooner than later.
No, that's great. Thank you so much. So we're coming up. We're getting close to the end of our times here. So I wanna jump into our last kind of poll question, and then we'll jump into audience Q&A. So the last question that we've got for everybody today in our kind of webinar polls is, what is the biggest risk your company associates with using open source software? And again, if you can't see all the answers, please scroll down. It's interesting to see in the back end kind of how the levers are moving around. It's a bit of a horse race here between the options. Give everybody a little a quick second here, and then we'll jump in. Okay, looks like it's kind of come to an end, and as I would expect, security vulnerabilities is a big thing. It's obviously a topic that is talked about quite a bit, so it's not surprising to me that security vulnerabilities is the biggest, the overwhelming winner when it comes to the biggest risks. So jumping into kind of audience questions, we've gotten quite a few actually, and I want to start with you, Mark. You, you know, one of the things that was talked about throughout is this idea of transparency and trust. And how do you think, what are the methods that we can use to gain transparency when you talk about open source software, and specifically when you talk about open source software in the use of in proprietary software, where you're not going to necessarily have access to the entire code base, or the organization may not be willing to share as much as some outside resource. And then if you talk about a pure open source software where you might not be able to have a regular communication with the developer. You're on you're muted.
There we go.
There we
Eventually I'll
go.
get there. When I look at, answering that in the context of enterprise software, there are opportunities to have an understanding with regards to what are some of the best practices that they have looked to implement in the development of their software. You may not get access to the actual source code themselves, but in regards to, let's say, a banking, are they utilizing PCI DSS, having access to their SOC 2 report? There are certain qualified avenues in order to get confirmation to build that trust. But again, as Ron said, it's how much do I trust you enough to use your software? It's different as opposed to looking at the open source solution. When you look at the open source solution, you do have visibility in most cases to look at the source code, but then when you're looking at actually implementing it into the enterprise itself, what quality controls are in place from all the contributors. I mean, we're not looking at just a subset of contained employees. It could be thousands of unknown entities that are actually providing input into that and lines of code to that code base, that source code. Where are you, if you can, utilizing and implementing SBOM to get attestation and provenance with regards to the libraries, but then more so the dependencies within those libraries themselves. You look several layers deep, and there could be a dependency in there from a threat actor nation that we know of. What are the mechanisms in place? So it's the due diligence goes on the company that is releasing or providing the software, but it also due diligence comes into play of the consumer themselves in asking the questions to ensure that their level of comfort and trust is there before they install that first line of code to use.
Yeah, no, absolutely. Corey, I want to take a slightly different approach with this question for you. You and I had a recent conversation about this idea of having, very much the kind of the incumbent organization, or the need to really diversify your technology stack. How do you address open source software when you've got a very narrow, very um, you know focused technology stack?
This I so this is a very big policy question, very big national question. I mean, when you look at it big to small, I mean, take the cloud environment as an example, not the conversation we're having, but there are three hyperscalers, right? Like, in when Ron, oftentimes you brought up the analogy to, unsafe at any speed, right? The safety mechanisms that we had built in the cars, but with cars you have a choice, right? The consumer has a meaningful choice. You don't really have that all the time in your technology stacks. There's one, two, three choices you can really have, and who's making those decisions is all oftentimes segregated from a management level, a C-suite level, like an employee. They don't have a choice in what email or what open source code the company has decided to use. And so it creates a really unique environment. And I do think it goes back on those choke points that we look at, and it really is like risk is both a function of proximity and position. Like, how close are you to the risk, and what position do you hold in the organization? And I think if we can get the folks making the decisions when bringing software into their stacks to really do I mean, even a low, medium, high, like what are we going to use this software to do for our organization? How critical is it to our mission? Is it mission critical? Is it, a must have, should have, want to have? And then start thinking back through that. But I mean, these are tough questions, and I mean, we've had in the security space a lot of bigger issues come up recently, and it hasn't. It's very clear the market doesn't value security maybe the way that the folks in this either listening in the audience or I know certainly sitting here would. And so when you think about the sort of the disconnect between market factors and security requirements, there's also real issues there. And I don't know how you bridge that chasm, but we need to start figuring that stuff out. And then I default back to it's going to take all of us. There's not a single entity or a single actor that can do it, and that's certainly true in the open source software space.
Yeah,
Great,
I
thank
just
you.
I think that's a
Yeah.
great comment, Corey. I like to use analogies, and I'm trying to think in the rest of the world that we live in with the things like, I look at the stuff that we get from industry as a black box, pretty much. You buy a smartphone, you buy a tablet, you buy a laptop, you buy any type of computing device. It's a black box. So you have a user interface, and that's probably all you know. Can you think of any other industry? Let's say, for example, the pharmaceutical industry, produced, medicines. They say it's a black box. We're not going to tell you what's inside it. You just take it. Or the food industry, there's a box on the shelf. All you see is a picture, of the food. They don't tell you what's in it. I mean, there's nothing else that we do when it comes to things that matter, your safety, your health issues, or things that really matter. There should be transparency in things that can be life threatening. And this, if we were having this conversation 2 decades ago, I wouldn't be as passionate about it because the blue screen of death never hurt anybody. But today, the blue screen of death can kill people because the computing technology, the software and the firmware that's driving these cyber physical systems, it's so tightly integrated and so complex, and we know very little about the effects of what could happen if something didn't go the way we thought it was. That's the whole notion of trust today, in the notion of trusting our systems. It's not about perfection. It's just about giving me more knowledge before I plug that computer into a device, whether it's open source going into proprietary software. It's all the same thing, because once that system gets rolling, it has a capability. It takes on a life of its own. And single points of failure could be devastating, as we saw with some of the more recent cyber attacks. They're well placed, and they go out to hundreds and thousands of consumers through whatever process they're using to distribute that software. And we just have to do a better job at defining due diligence, and then making sure that we can enforce due diligence across the spectrum. I'm not talking about regulation, but there's some, could be market forces, whatever it is, but we need that transparency so we can make better decisions on things that are potentially life critical.
Absolutely. Well, we're coming up on time, and I want to, make sure we have time to wrap up and get everybody out, on time. Thank you all. Thank you, Corey. Thank you, Ron. Thank you, Mark. Mark, thank you to Cloudbees as well. I want to give you just a quick, 30 seconds, 1 minute, just quickly tell us a little bit about Cloudbees.
For those of you unfamiliar with Cloudbees, Cloudbees is it's the leading software platform today for enterprises that are really looking at developing and innovating their own software based off of the open source Jenkins 13 years ago. Now it's evolved into so much more, allowing for that enterprise support for that set of guidelines, best practices that we've built trust with many of our customers with regards to creating a platform that allows them, so when they're building their own software, it's scalable, it's compliant, it's governed, and it allows them to really drive forward what they're developing to match up with what the business initiatives are, so that they can deliver that value to their end customers.
Great. Well, thank you, Mark. Thank you. Cloudbees has been a great partner to ICIT. We really appreciate it. Reminder, everybody, you will receive a survey after this. Please complete it. Cloudbees is going to be offering $20 charity gift card if you complete the survey. Any questions we didn't get, we'll get to the panelists and find a way to share them with the answers with you all. Please follow ICIT. We've got a lot of really exciting things on the horizon. I know Corey is really excited to share that with everybody here in the very near future. Thank you all for joining, and we will see you soon. Thank you.
Thank you.
Thanks, Ron.